So hello, good evening, everyone. It's always a pleasure to be with you. Whenever I share any series with you, I'm always so delighted. So today we are going to have another bonus package. It's called Laboratory Posting Practice Questions. Usually for this part, that's the part 2, is usually for people that will write their first professional. I would advise that those who are going to write their first professional should watch this video as well as the part 1 video. Both of them together combined will give them enough practice questions to be able to deal with the MCQ that will be coming up. So please, if you would hold on, we'll start very soon. So like I have said, today we'll be doing clinical chemistry laboratory posting exam practice questions, part 2. And it's usually for those who are writing the first professional exams, but other medical students as well as nurses can also use it for practice for their laboratory posting exams also. So before we continue, as always, I would always ask that you like, share, subscribe, and comment on our videos. And I want to thank you so far for all the support you have been able to give to us. So question 1. DASH is a test used to determine glycemic control of diabetics. A, fasting plasma glucose. B, prostate-specific antigen. C, glycated hemoglobin. D, calcium. And E, hormonal assay. So what do you think is the question? This is very, very easy. If you said C, you are correct. Usually the glycated hemoglobin helps us to look at glycemic control over a period of 3 months, because that is the lifespan of a red blood cell. The fasting blood glucose, on the other hand, will just show you at a point in time what is that person's level of sugar, but it doesn't show anything about control. Question 2. Container for collecting blood meant for glycated hemoglobin contains A, potassium EDTA as anticoagulant. B, sodium citrate as a preservative. C, potassium oxalate as an anticoagulant. D, lithium heparin as an anticoagulant. And E, sodium fluoride as a preservative. So what's your answer? I will choose potassium EDTA as an anticoagulant. All right. So question 3, what is NaCl reagent used for? It's certainly not used to detect glucose, certainly not used to detect creatinine. It's not used to detect the presence of ketones. If you had watched the part 1 video, you'll see that you use the keto sticks or the Nitrocide reagent, Rutherus mixture, to check for ketones, and it's certainly not used to test for sucrose. So the only answer that is remaining will be C, testing for the presence of ammonia. You use clinicistics for glucose, you use Jaffe's reaction, okay, for creatinine, or your ZD's method, whatever method you're using, and all that. So question 4, NaCl reagent is a combination of A, an aqueous solution of potassium iodide, mercury chloride, and potassium hydroxide. B, potassium iodide in alkaline solution. C, NaCl reagent 1 and 2. D, mercuric salt stroke sodium iodide in alkaline solution. E, sodium iodide in alkaline solution. Usually, if you're giving components of a certain reagent, you should be very specific. So I would go with an aqueous solution of potassium iodide, mercury chloride, and potassium hydroxide. All right. So question number 5, a flame photometer measures A, urea, that's not an electrolyte, you should know. B, creatinine. C, hormones. No. You use ELISA mostly for hormones. Bilirubin. No. And E, sodium and potassium. Correct, because these are ions. So it can be used, the flame photometer can usually be used to measure cations. So question number 6. One use of serial dilution in clinical chemistry is to A, check the suitability of a sample. B, check the quality of a sample. C, check the linearity of a colorimeter. D, prepare a calibration curve. E, to check the quality of the reagents. So what do you choose? Is that your final answer? All right, I will choose D. It is usually used to prepare a calibration curve. 7, how would you prepare 1 mole per liter solution of NaOH? Usually, whatever you want to prepare, a 1 mole solution, you have to put the grams that will correlate with its molar mass. So, do you know the molar mass of NaOH? That's the question you should answer. So, A, 40 grams of NaOH in 100 ml of distilled water. B, 40 grams of NaOH in 1 liter of distilled water. C, 20 grams of NaOH in 1 liter of distilled water. D, 38.5 grams of NaOH in 100 ml of distilled water. E, 35 grams of NaOH in 1 liter of distilled water. Okay, so the molar mass of NaOH is approximately 40 grams, and 1 liter of solution is not the same as 100 ml. So A is not your answer. Your answer will be B, that is 40 grams of NaOH in 1 liter of distilled water. So potassium is predominantly an intercellular cation. B, extracellular anion. C, intracellular cation. D, extracellular cation. E, interstitial cation. I'm sure we all know about cations and anions, and your potassium is predominantly an intracellular cation. Question 9, the normal range for sodium for our locality is A, 132 to 145 millimoles per liter, B, 96 to 108, C, 88.6 to 177.2 millimoles per liter, D, 3.2 to 5 millimoles per liter, E, 4.2 to 6.4 millimoles per liter. What's the, okay, that's sodium. Sodium is, you will usually be, it would not be 4.2 to 6.4. No, certainly not. D, 3.2 to 5.0, that's for potassium. C doesn't even correspond to anything, because even if you're looking at creatinine, creatinine should be in micromoles. You must always note the unit. All right, so if I ask the normal range for creatinine and you rush to say 86.6 to 177.2 millimole, you're wrong. It's actually micromole. So watch for the units. There are trick questions like that. Then being 96 to 108 millimoles per liter, that's chloride. So it remains A, 132 to 145 millimoles per liter. That's the normal range for sodium. All right, the titrant in the scales and scales method of chloride titration is A, 1 normal mercuric nitrate, B, 2 normal nitric acid, C, 1% diphenyl carbazone, D, 0.1 normal mercuric nitrate, E, distilled water. The answer is 0.1 normal mercuric nitrate. Question number 11. Specimen Question 11. Specimen containers for blood liver function tests may contain potassium oxalate. No, we want serum. So A, it's out of it. B, EDTA out. Fluoride out. Anything with anticoagulant is out. So your answer will be D, your silicone gel activator. So next question, 12. The specificity of Yazdi's modified method of creatinine estimation is achieved by incubation is usually at body temperature, so it will be 37 degrees for 25 minutes. So question number 13, the following test can be done routinely on cerebrospinal fluid. A, glucose and protein. B, urea and creatinine. C, sodium and potassium. D, alkaline phosphatase and AST, E, chloride and magnesium. I would go with glucose and protein because that is what is usually routinely done on cerebrospinal fluid, unless you have other special tests to ask for. Then, using the back titration method on the bicarbonate bench, the acid used is what? The answer is 0.01 normal H2SO 4. Question: what test would you use in the investigation and diagnosis of meningitis? This actually seems similar to the other question. So if you know the answer to the other question, you should know the answer to this. So EUC analysis, no. 24 hours urine protein analysis, no. It's not urine, it's CSF we are using. Analysis of total protein serum or total serum protein, no. We are using CSF. Fasting lipid profile, no. We are using CSF. CSF, glucose, and protein estimation. That is correct. Question 16. Dash is a standard well. A, test tube. B, beaker. C, glass pipette grid C. D, volumetric flask. E, conical flask. The answer is your volumetric flask. That is a standard glassware. Which of the following instruments can be found in the chemical pathology lab? A, Selectra SL Pro Clinical Chemistry Auto-Analyzer. B, Automatic Blood Cell Counter. C, Incubator. D, Automated Tissue Processor. E, ESR Western Green Stand. You all know that the automatic blood cell counter, you find it in hematology, incubators, you find it sometimes in microbiology, also in hematology. Automated tissue processor is in histopath. ESR Western Green Stand is in hematology. So that leaves you with this chemistry auto-analyzer. You should have known it. It's there. It's glaring. Clinical chemistry auto-analyzer. So the instrument that relies on the Beer-Lambert's law as the basis of operation is called a benchtop centrifuge. Electronic balance. Spectrophotometer. Vortex machine, the deionizer. What's your answer? It's very glaring. I will go with spectrophotometer. If also you see a colorimeter, that also follows the Beer-Lambert's law. So you can have your answer as either spectrophotometer or colorimeter. So during the transport of serum specimens for routine bilirubin estimation, it should be stored in silicon formal normal solution. Wow. Wow. It should be stored frozen at -20 degrees centigrade during the period. C, it should be stored in silicon gel. D, it should be stored in silicon solution. E, direct sunlight should be avoided. Bilirubin is photolabile. So if you expose it to sunlight, its concentration will reduce because the bilirubin is going to disappear. That is why if you do have a baby with jaundice, the home treatment sometimes is to sun the child, okay, because bilirubin is photolabile. So I would go with E, direct sunlight should be avoided. Question 20 says an example of an explosive semisolid chemical is A, NaOH, B, picric acid, C, sodium citrate, D, sodium bicarbonate, E, sodium azide. This is a bit hard. This is a bit hard. So let's see. Explosive, picric acid. All right. So question number 21. The ideal way of waste disposal technique is A, by incineration. B, dump it into a pit. Who wants to do that? C, recycling and sterilization at 100 degrees centigrade. They don't sterilize it. Don't do that. Don't do that. D, flushing down the drain to the sewage system. Where will it end up? In the river. E, boiling at 100 degrees centigrade. Usually you should incinerate it. Normal human urine is A, amber and clear. D, tastes quinonic. C, assumes ammoniacal odor when freshly voided. D, the odor is lightly aromatic on standing for hours. E, pale yellow and cloudy. I would go with A. It's amber and clear. Amber is like straw colored. It doesn't taste bitter. And it's not ammoniacal when you freshly void it, unless there's something wrong with it, maybe UTI or something. It's only when it stands that it becomes, has that ammoniacal odor. All right, so question number 23. 24 hours urine volume usually ranges from E, 1,500 to 2,500 mils. That's your normal range. Question number 24. Which of these options is correct? The following sample is usually received and used for CSF, protein and sugar quantitative tests. B, CSF for protein qualitative tests. C, whole blood in potassium oxalate for RBS. No. D, whole blood in lithium heparin for HbAIC, A1C, glycated hemoglobin. E, plasma gotten from EDTA vacutana for LFT. No, you don't want to be using all those, okay? So between A and B, which one do you think is the correct answer? Remember that one is quantitative, the other one is qualitative. So usually if you are going to go through the rigors of getting CSF, you want to do a quantitative test. So your answer is A. Laboratory safety. Laboratory safety begins with A, recognition of the fact that all specimens in the laboratory are potential hazards. B, application of common sense. C, good personal behavior and habits. D, respecting laboratory personnel. E, respecting laboratory scientists. I would go with A, because if you do treat every sample as potentially hazardous, you would be able to know that you should carry out everything that helps you to have a good laboratory practice, okay, where your lab could that. But if you do not have that awareness that surfaces you might touch, specimens you might touch are all hazardous, you may not be able to take care of yourself. So what is the principle of the Albustics reagent? A, it is based on the principle of protein error of indicators. B, it is based on the Beer-Lambert's law. C, it is based on the theory of relativity. My answer would be it is based on the principle of protein error of indicators. That is why when you dip that indicator into urine that has protein, it changes color. That is also another reason why if you do have extreme alkaline conditions, you may also have a positive color, which is not true for protein. So that is a limitation of the Albustics reagent because it is based on this principle. So if you have extreme changes, especially towards the alkaline region, you may have false positive results. 27. Albustics results can be affected by A, room temperature, B, low pH, C, ascorbic acid, D, urobilinogen, E, extreme alkaline pH, and that is the answer. So question 28, to confirm results from Albustics, we could use A, 5% TCA, B, 25% SSA, C, 20% SSA, D, 25% TCA, and E, 5% SSA. If you don't work on the bench, you may not know this. But what you use to confirm results from Albustics is your 5% TCA. All right, 29, question 29. Which of the following methods can be used for serum bicarbonate estimation? A, Van Slyke titrimetric method. B, ISC method. C, scales and scales method. D, colorimetric method. E, the use of pH meter. So your answer is the Van Slyke titrimetric method. That is what you use for bicarbonate estimation. Your scales and scales is for chloride. All right. So question number 30. Dash can be detected in urine with combined strips. You are having a panel of answers. When you have something like this, please look through the answers very, very carefully, because some people may put a panel of correct answers and then insert one wrong one. That invalidates that particular option. So we have nitrite, protein, glucose, blood glucose, ketones, pH. Then B, you have creatinine, urea, electrolytes. Okay. D, glutathione and selenium. D, renal calculi and stones. E, uric acid, nitrogen, and ammonia. Usually you detect not that. You can't detect creatinine and urea with this. You detect nitrite, proteins, glucose, blood, and ketones with pH, and pH with the combined strips. All right. So question number 31. The function of the lab deionizer includes A, production of water with lower electrical conductivity and high resistance. B, production of pyrogen-free water. C, water purification based on steam boiling. D, production of quality distilled water. E, production of water with acidic pH. My answer will be A, because what you do when you have deionized water is that you removed as much ions as are possible from water. That would lower its ability to conduct electricity. So you are going to have lower electrical conductivity, and also a high resistance to the movement of electricity. Okay. So the next question, 32. State the main practice for laboratory water bath, the maintenance practice for laboratory water bath. A, by maintaining adequate water level. B, balancing the tubes by ensuring equal and opposite weight. That is for the centrifuge. C, avoid using the hand to stop the rotor. That's for the centrifuge. D, make sure the test solution is below the water level. No. D, do not cover the tubes or plates to avoid contamination or dilution. So A, you always maintain an adequate water level so that the coil for the water bath does not go dry and burn up. Question 33. During transport of whole blood specimens, temperature should be maintained at A, between 32 to 48 degrees centigrade. B, should be by freezing at -20 beyond 24 hours. Remember, it is whole blood that you're transporting. Between 2 to 8 degrees centigrade for 24 hours, that is at fridge temperature. Between 22 to 25 degrees centigrade for 24 hours, that is at room temperature. Between 28 to 35 degrees centigrade. In Nigeria, if you are living in the north, it could have this kind of this kind of temperature. So the answer will be between 2 to 8 degrees centigrade for 24 hours. This is because you're transporting whole blood specimens that you don't want to lyse. If you were transporting serum or plasma or some other thing that can be frozen, you could actually use -20 beyond 24 hours. But since you're transporting whole blood, you want them to be whole, you don't want lysis, so your C will be your answer. Question 34. An example of explosive and flammable chemicals in clinical chemistry, whether it is in clinical chemistry, microbiology, and hematology, it will still explode. So what is an example? You have ether and alcohol, mercury chloride, sodium citrate, sodium bicarbonate, and sodium hydroxide. Our answer will be ether and ethanol. Those are highly flammable liquids and also highly explosive liquids. So clinistics is A, monostrip, B, dual strip, C, multi-strip, D, one-stage reagent, E, Benedict alternative reagents. Clinistics is a monostrip. It comes as just one you have only one, what do they call it, test spots there that test for only glucose. So we call it a monostrip. A dual strip will be your Combi 2. Multi-strip will be your Combi 9 or Combi 10, wherever you are. Some people use Combi 9, some people use Combi 10. One stage reagent is not Benedict's alternative reagent. Your answer is a monostrip. So potassium value is used occasionally to determine body mass index. I guess you know the formula for body mass index. Okay, I think it's weight over the square of height in meters square, weight in kilograms over the square of height, okay, meter square. Then acid-base balance, no. Rate of metabolism, no. Anion gap, yes. Why I say anion gap is because there are two types of formula for calculating anion gap. All right, there's one that has only sodium minus chloride and bicarbonate, while there's another one that has sodium plus potassium minus chloride and bicarbonate. Okay, so you could actually use it occasionally to determine anion gap. Turbidity or cloudiness in urine may be associated with A, the presence of superlative bacteria and leukocytes or proteins in the urine. B, presence of trace amount of pus cells. C, in non-menstruating women. D, presence of considerable amount of crystals in acidic urine. E, urine from uremic acid. No. So your answer will be A. Usually if you have a lot of bacteria in urine and leukocytes or protein, you will have a cloudy urine. So which test is necessary in the investigation and diagnosis of meningitis? Have we not done this before? Yeah, I think we have. So the answer is CSF glucose and protein. Question 39. After a 1:5 dilution of a plasma sample, the glucose concentration was 6.0 millimoles per liter. What is the actual plasma glucose concentration? So how would you calculate that? First of all, you did a 1:5 dilution, which means you took 1 part of the sample and 4 parts of the diluent. Okay, so that's a 1:5. So your multiplication factor, your dilution factor will be 5. All right, so your answer would be now 6.0 millimoles times 5. That will not give you 30. Question 40. A standard solution of a chemical substance is A, or the standard solution of a chemical substance, A, is used as a reference to assign absorbance to other solutions. B, is a solution of known concentration. C, can be classified as primary, secondary, and tertiary standards. D, is used to control analytical methods. E, cannot be used in a calibration curve. I think the only true sentence here is B. It is solution of known concentration. You can't use it as a reference to assign absorbance. No, you measure the absorbance of other solutions. All right, so that is that. Question 41. Biuret test is used for the quantitation of what? Of proteins, usually. For lithium, you use your either AAS, atomic absorption spectrophotometry, or even a flame photometer that has a lithium cathode can be used. Lithium electrode can be used. Then sodium flame photometer, AAS, urea diacetyl monoxide method, or the urease method. Bicarbonate, you could use your back titration for it or any other suitable method. So biuret is for protein. Then 42, Benz-Jones proteins. Benz-Jones proteins are otherwise known as paraproteins. Okay, you find them in urine in people that have certain types of cancers. Okay, so A, they are not filtered by the glomerular. B, they are normal proteins of immunoglobulin light chain. C, are found in serum and urine of patients having brain tumors. D, can be detected by Gerhardt's test. E, can be detected by boiling test. What's the answer? Don't mind me. I'm trying to think of the answers I'm asking you. So what do you think is the answer? It's E. It usually is detected by boiling test. All right. So when you boil it to, I think it's about 50 or 60 degrees centigrade, the turbidity appears. If you boil it further, it disappears. So it's by the boiling test. Okay. So question number 43. A solution contains 300 grams per liter of sodium chloride, which has a molecular weight of 58.5. So what is the molarity of the solution? If I were you, what I would actually do would be to divide 300 by the molecular weight. And if you do that, your answer will be 5 and a fraction. So your answer will be about 5.1 moles, all right, per liter of solution. So question 44. Which of the following best describes universal precautions? A, treating all specimens as potentially biohazardous. B, testing all patient specimens for anti-HIV 1 and 2. That is expensive. C, wearing personal protective equipment in the lab. D, washing hands immediately after removing gloves. E, washing your hands even when your gloves are on. So what is the correct answer? The best universal precaution is to treat all specimens as potentially hazardous. You know why I was laughing at B? That would be quite expensive because the HIV kits are expensive. All right, so question number 45. What is the scientific measurement unit for volume? That's very easy now. It's A, liter. What? Okay, in adults, question 46, in adults, polyuria is associated with a urine volume greater than 2.5 to 3 liters per hour, or an excretion rate of greater than, how would you get this answer? All right. The answer is A, 3 mils per minute, B, 5 mils per minute, C, 6 mils per minute, D, 0.5 mils per minute, E, 2 mils per minute. So excretion rate greater than 2 mils per minute. So question number 47. What is the scientific measurement unit for height? Meter. Question number 48. Feces gets its brown pigmentation from A, stercobilin, B, stercobilirubin, wow, C, stercobilinogen, D, stercobilin, E, stercobilin particles. I would go with A, okay? Though A and D look similar, but the spelling of D is wrong. So A is your answer. Question 49. The anion gap in the plasma or serum refers to the difference between the most prevalent cations and anion. It is calculated according to this equation. You remember I told you there were 2 equations, so you should be able to answer this. I told you before, in the question before. So your answer is sodium minus chloride and bicarbonate. But there is a second formula where it said potassium plus sodium minus chloride and bicarbonate, or minus chloride minus bicarbonate, all right? Then my final question. In a hemolytic crisis, bilirubin levels are A, decreased, B, normal, C, increased, D, unchanged, E, direct bilirubin is much higher. Hemolytic crisis, you are going to have a lot of bilirubin being, a lot of red blood cells lysing. So what do you think will happen to bilirubin levels? These are end products of red blood cells. They will be increased, all right? Okay, so that is my final question. I want to say thank you very, 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 very much for all that you do, for your support and all that you do. Till next time, God bless. Take care, and I will see you in the next video. Bye.